get some hints for you for this Chapter 15 quiz. It shouldn't be that hard, but alright, let's go. For this one, all I'm going to say is that PO4 is phosphate. Alright, if the reaction quotient is equal to the equilibrium constant, that means that if there is solid present, it's being formed at the same rate that it is dissolving. So if Q were any higher, that would mean that the solution was supersaturated. And thing to assume here also is that nucleation sites are present. So if you do add more ions somehow, then the solution won't actually become supersaturated. You can assume that there are nucleation sites where a precipitate could form. Alright, and only thing I want to say for this one is there are 3 silvers per phosphate here. Oh, and these three are just, just look at the stoichiometric coefficients. These aren't too difficult. Alright. Yeah, we're assuming that Ag2SO4, the silver sulfate, is a solid, and then it dissolves into the separate ions of silver plus and SO4 2 minus. And ask yourself, do solids appear in the equilibrium constant expression, or solubility product constant? Okay, and this one already has a hint of the common ion effect. So all I'm really going to say here is that a higher pH means more basic, which means more hydroxide present. Solubility product. The KSP here is just the product of the 2 ions. And let me just ask you, if we were to increase by a little bit the values of the concentrations of these ions, would we still come up with a value under our KSP? Yeah, so could we increase these values any and still get a Q that's lower than our KSP? Alright, so looking at these KSP values, the silver chloride is like a billion, or maybe like a little more than a billion times more soluble than our silver iodide. So the question is there a billion times more chloride in our KCl than there is iodide in our Ki? I'm going to let you guys handle these two. Okay, hint for this one. It already tells you there's a Lewis acid-Lewis base reaction. Something to know is that nitrogens almost always have an electron pair coming out of them that might be donated somewhere to something. Well, let me also tell you that metals are generally positive and electron pairs are negative. All right. Yeah, and again, why is something negative? It's because it has extra electrons compared to protons. So a negative species might want to share those electrons. And that might help you for all of these, both of these Lewis acid, Lewis base questions. All right, and then a hint for this one is that you're going to end up with 4 hydroxide groups instead of 3. So you're going to end up with 4 areas of electron density on a central boron atom. All right. I hope these hints were helpful. If they were just frustrating or something, or if I didn't say enough, feel free to shoot me an email, ask further questions. All right. Good luck.